Oh yeah, you're right. There we go. I did it. All right, decision-making strategies. It's kind of interesting to think about. There's a lot of different ones of these. These are just basic. But there's a decision-making strategy that I really enjoy, and that is rating something that you want to do, 0 or 1 to 10. 10 meaning that you really want to do it, and 1 being I absolutely don't want to do it. But you take away the number 7. So what does that mean to me? That would mean that if it's an 8, a 9, or a 10, okay, that feels good to me. I really do want to do it. If it's a 6, I bet you I want to do it because it'll make somebody else happy. If it's a 5, I don't really want to do it, right? I mean, if it's a 4, I don't want to do it. You know, 7 is that odd number that if for some reason you just take it away and you're making decisions based on ranking it, how bad you want to do it. 10 being, you know, I want to do this so bad. And you take away the ability to choose 7, the wishy-washiness of that number. It might make it a little bit more clear.
I appreciate your boldness.
That's a decision-making strategy. So let's look at some other ones. So different cognitive strategies are used when making decisions depending on the type and number of options available to us. The single feature model, all right, right here. In order to simplify the choice among many alternatives, you base your decision on a single feature. So faced with an entire aisle of laundry detergents, you base your decision on money. If you want the best laundry detergent, you get the most expensive laundry detergent, right? If you're looking for the cheapest, then you're looking for the cheapest, right? I mean, that you're making a sole decision based on one single feature, which just happens to be money right here. The additive model, systematically evaluating the important features of each alternative. So you rate the factors using an arbitrary scale, -5 to +5. If a factor has strong drawbacks, you give it a -5. If it is advantageous, you give it a +5. Then, at the end of it, you add up all of the ratings for each alternative to reveal the best overall choice, and boom, you make it. I like this one whenever it comes to the thought of which college you want to go to. All right? This would work well for that. Money, major, social experience, athletics, how far away it is from home. All of those things can be factored in just like this, and you can assign an arbitrary number to those things. And at the end, you could add it up, and you really could find your best potential place to go. The elimination by aspects model. So evaluate all the alternatives, one characteristic at a time, typically starting with the feature you consider most important. So if a particular alternative fails to meet the requirements, you scratch that off the list of your possible choices. Do this until there's just one alternative left. Again, you could do this again with choosing colleges. Good decision makers adapt their strategy to the demand of the situation. Which reminds me of when I coached soccer, it reminds me of a quote that I used to hear. The game demands, and the player responds. I don't know if you've ever heard that before, but you know, life demands, and the person responds. That's pretty much what it comes down to. All right, decisions involving uncertainty, which just happens to be a lot of those decisions that we make that really stick out to us probably. But imagine this, you're late for an appointment and you face the decision of, should I speed to get there on time? You have to estimate the probability of this factor, getting pulled over for speeding. So we have the availability heuristic, which is a shortcut. So it is your most recently available memory or instance of that particular situation, getting pulled over for speeding. So it's a strategy in which the likelihood of an event is estimated on the basis of how readily available other instances of the event are in memory. So this is used more often when relying on information in long-term memory to determine the likelihood of an event happening. So when instances of the event are easily recalled, we tend to consider the event as being more likely to occur. And let's say that your friend just got a speeding ticket. That would mean you're like, oh, should I speed right now? Ooh, I'm so late right now. Oh, Johnny Susie got a ticket yesterday going 70 and a 35. What? Yeah, when a rare event occurs, it may leave a vivid impression on us, causing us to overestimate the likelihood of the event taking place. Lottery commercials showing winners, not losers. They're trying to get you right there. Then we have a representative heuristic, which is another shortcut. How close are you to the person, the stereotype of the person who gets pulled over? Are you young? Do you drive a two-door red car with a spoiler? You know? All those things come into play. So a strategy in which the likelihood of an event is estimated by comparing how similar it is to the prototype of the event, which is the most common example, right? So more likely to be used when people compare different variables to make predictions. Are you representative of the person who gets pulled over? A teenager in a sports car or a parent in a minivan? You know, are you going to be pulled over? You know, do you drive what looks like an undercover cop car? Because if you do, you're probably not going to get pulled over. So Maria is a perceptive, sensitive, introspective woman. She is very articulate, but measures her words carefully. Once she is certain she knows what she wants to say, she expresses herself easily and confidently. She has a strong preference to work alone. Is Maria a successful fiction writer or a registered nurse? This is where schemas and scripts mess with you. Because if you think about it just here, what does Maria represents what? A successful fiction writer or a registered nurse? A successful fiction writer. But now let's think about it logically. Okay? What are the chances here? The chances are more great that she's a registered nurse. It just works out like that. There's more female registered nurses out there than there are female successful fiction writers. And that's not saying anything, you know, I'm just going by numbers. And so you go by numbers and then you're just like, oh, okay, Maria's probably a registered nurse. But you go by this representative heuristic and you're like, oh, she's a fiction writer. By the persistence of unwarranted beliefs, so we have some bias effects here. So 4 obstacles to logical thinking described here can account for much of the persistence of unwarranted beliefs in pseudoscience or other areas. So we have the belief bias effect. This occurs when people accept only the evidence that confirms their belief, rejecting or ignoring all evidences that does not. You see this a lot in senior project papers. They just forget the other side. And you know, you forget the other side, guess what? That means to me that you really didn't do the research that I think that you did. You know, you're only going to things that confirm, you know, your belief in it. And that kind of leads to this one, confirmation bias. The strong tendency to search for information or evidence that confirms a belief, while making little or no effort to search for information that might disprove this belief. You've definitely heard this. You've definitely experienced this before. You've done this before. I know you have. I know I have. The fallacy of positive instances, the tendency to remember uncommon events that seem to confirm our beliefs, and to forget events that disconfirm our beliefs. Basically saying, you know, I'm the best FIFA player in the world. Oh, you are? Have you lost? Yeah, I have lost. But guess what? I don't remember them. I only remember the wins. All right, that would be the fallacy of positive instances. And then the overestimation effect, the tendency to overestimate the rarity of events. Man, every time I think about this person, they end up texting me. No, they don't. It's just rare, so you remember it more often, and then all of a sudden you're like, oh my gosh, this always happens. And no, it doesn't. It's just so rare that you actually remember it more. All right, language and thought. Oh, we'll be pushing it. So, language is a system for combining arbitrary symbols to produce an infinite number of meaningful statements. The purpose of language is to communicate, obviously. So it requires the use of symbols. These symbols can be sounds, written words, or in case of American Sign Language, formalized gestures. Symbols may be similar to their meaning, so words like boom or pop. But for most words, however, the connection is arbitrary. So ton is a small word, but it means a big amount, a large amount. Because the meaning of most words is arbitrary, it makes language tremendously flexible. Syntax is important. So it's a set of rules for combining words. The example here, the boy ate the giant pumpkin versus the giant pumpkin ate the boy. Same words, different meaning. And language is generative or creative, infinite number of new and different phrases. And then language is also characterized by displacement, so communicating meaningful thoughts about ideas, objects, or activities that are not physically present. That's what I can do right here, right now. I can tell you stories. I can do whatever I need to do to create this thing inside of you through my words. How language influences thinking. So there's something right here called the linguistic relativity hypothesis. It's the hypothesis that differences among languages cause differences in the thoughts of their speakers. This makes sense. I mean, think about how many words we have for snow. Not very many. Then you think about how many words Eskimos have for snow. And it's over 100. So they actually think and can think about snow a lot more and a lot differently than we can. We just don't experience that often. And we also are hindered by our language. It only gives us a couple of flurries, blizzard, snow, sleet. I mean, that's what we're working with, and they're working with hundreds of words like that. So it actually does hinder our thought process. And then animal communication and thinking. If you get a chance, watch this video on Kanzi. He learns how to speak through a lexicon here. So he was asked what kale was, or how he liked kale, or to describe kale. And kale's not on this board, but lettuce is, and dirty is. And he pointed to dirty lettuce. They say, and they think, that the descendants from Kanzi, so he had a son, I can't remember his name, I think it might be Tico. Might be the first chimpanzee, bonobo, to speak a word. So we'll see. We'll see what happens there. This is, for all intensive purposes, Kanzi's mother. So again, just go through that. Animal cognition or comparative cognition, study of animal learning, memory, thinking, and language. Ah! We did it! Hit me with that theme song!